I want to start out talking about routing by looking at a map. This is Google Maps, and to get a route from, let's say, Roanoke to Norfolk, we would go and ask Google Maps to give us a route, and it would tell us the route to take. It might say something like, get on Interstate 81 and stay on Interstate 81 until you get to Stanton. At Stanton, get on Interstate 64 and take Interstate 64 all the way to Norfolk. We'd go through Richmond, we'd go through a number of other places. While we were on this route, there would be other options to get off. Like in Lexington, we could get on 64, we could get off in Lexington. When we got to Stanton, we could keep going on Interstate 81. But we follow the directions that were given. Routing data is a similar, well, it's actually the same concept. It's a similar process, except that we use some very specific language in order to do that. I have here a topology that has 1, 2, 3, 4 routers, that has 1, 2, 3, 4 different networks as both sources and destinations. And between the routers, we have subnetted the 192.168.5 network with a 30-bit subnet mask, which means that we have exactly 2 addresses, a network address and a broadcast address, the unusables that connect the networks together. If I want to go from the 192.168.100.0 network to the 192.168.103 network, I have to tell the routers how to get there. Without that information, they don't know what to do with the packets, and a router that receives a packet that it doesn't know what to do with simply drops it without message, just throws it away. So going from here, I would go from PC0 to the interface on my router, and I have made the interfaces on each of these routers the .1s and the computers the .2 addresses with a default gateway of the .1. So if PC0 on the one that has an address 192.168.100.2 wants to go to PC3 192.168.103.2, the first thing that would happen is it would send its packet to router 0. Router 0 would then require route information as to where to send it next. So we would have to tell that router, send all of the information that is destined to 192.168.103 network to router 1. Router 1 would then need to have route information that says sends the information to router 2. Router 2 would need the same thing, route table, routing information, to send it to router 3. Routers know about networks that are directly attached to them, so that once it gets here, the router then knows that it's a local network and sends the information to the switch, and then it can then be distributed to the specific device that it's destined for. Once it gets here, the information from PC3 has to get back to PC0. Again, default gateway, it sends its information to router 3. Router 3 now has to have routing information to get back to the source network, 192.168.100.0. It has to know to send information for that network to router 2, to router 1, to router 0. To do that, we use route tables. I've gone ahead and typed the routing tables into this image so that you can see what they look like. We have a thing called a default route, because on this end device here there's only one direction any of the information can go, and it's out of this interface to be sent anywhere except to the network that's directly attached to it. A default route uses the syntax 0.0.0.0 as the network address with a subnet mask of 0.0.0.0, and then I tell it to go to the 192.168.5.6 interface, the next hop, the next interface that this router can actually see. You have to send the information to an address that this interface can find, so they have to be on the same subnet. On this particular router, we can take advantage of default routes, and then we can have a route exception in here. The default route, most of the traffic goes out the 5.9 interface to the 5.10 interface, so we can put in a default route 0.0.0.0 with a subnet mask of 0.0.0.0 and tell it to go to the 192.168.5.10 interface. Again, most of the traffic will go in that direction. There is one exception though. The 192.168.100 network needs to go out interface 5.6 to interface 5.5. So I've given it the exception here with 192.168.100.0 network, subnet mask 255.255.255.0 goes to interface 192.168.5.5. And again, once it gets on the router knows about directly attached networks, and it will send the information to the required network. Again, going to router 2, I can take advantage of the default route. Most of the traffic is going to go out 5.10 to 5.9. There will be, again, one exception to the 192.168.103.0 network will go to interface 5.14. And when I get to router 3, again, the default route, all of the traffic goes out a single interface to one location or another. Routing, then that's all there is to static routes. Static routes, you just simply tell it one router at a time how to get from location to location. The thing that you have to remember is you have to have information that goes in both directions. If we go from PC0 network to the PC3 network, then we also have to have routes that allow the information to get back from the PC3 network to the PC0 network. Here's the topology that we were just looking at in Packet Tracer. So I can go into this one, and let's go from PC0, and you see I've already tried it out, PC0 to PC3. PC3 was 192.168.103.2. So if I go in here and ping 192.168.103.2, I'm getting a reply. The information is getting there and getting back. When I go into a router, the router device, I could go in and look at the routes, and the command here would be show IP route. Tells me, if I spell it right, well I did, the routing information. And this one says, and this is router 0 has a static route 0.0.0/0 that goes via 192.168.5.6. Notice that it does know that it is directly connected on Fast Ethernet 00 192.168.100.0. So the static routes work. We've shown that we can get from one location to another. Static routing for small networks is probably the safest thing to do because there's no broadcasting. We also have dynamic routes, which we'll work on in a different lesson, that we can configure dynamic routing protocols that automatically find the topology and create route tables that will change. The issue with dynamic route tables is they can become security issues. They are broadcast protocols so that you're sending the information to everyone everywhere. Route tables, again, the default routes are something that can save you a lot of time, because here, instead of having to type a route to the 101 network, the 102 network, the 103 network, I simply use the static that says, hey, everything goes out here. On this one, I took advantage of the static route saying most of the traffic goes in this direction, only one network goes in this direction. So the static route, or the default route, The default static route is the one that will be used unless there is an exception. If there's an exception to that route, that'll be the one that the device uses. That's it for static routing. Thank you for watching, and hope